Okay, so the second free response question from Unit 4 is a similar one to the one we just did. This one is about water flowing in and leaking out of a small tub. But for the first 10 minutes, water is flowing in to a tub at a rate of F, given by that function. And then starting at 5 minutes through 10 minutes, there's also water leaking out and is represented by the function L. Both F of t and L of t are represented in cubic feet per minute, and t is measured in minutes. And then one more function we have to work with is W, and W is the volume of water in the tub at any given time t between 0 and 10 minutes. All right, so for A, at time t equals 3, there are 2.5 cubic feet of water in the tub. Write an equation for the locally linear approximation of W at t equals 3, and then we're going to use it to approximate the volume of water in the tub. So again, this linear approximation locally is asking you for a tangent line approximation. So we need our point and we need our slope. So for the point, that's going to be W of 3. And it tells you in the problem that at time t equals 3, there's 2.5 cubic feet of water. All right, and then for the slope, we want W prime of 3. So let's start off with W prime of t. All right, so at 3, there is no water leaking out because water doesn't start leaking out until 5 seconds. So at time 3, we're just using the F formula. So rate that the water is changing at time 3. All right, so then in the calculator, we can just plug in 3 for t. All right, that's a 10. That's my thing's being weird. So anyway, I'm going to write out this whole decimal. So the final answer has to be accurate to 3 decimal places. So that doesn't mean throughout the problem you round to 3 decimal places, because that's going to mess you up. So it just means the very last answer is rounded or truncated at 3 decimal places. So whenever I do my problem, I'm going to use at least like 5 or 6 decimal places. You could use them all if you wanted to, or just pull it back up in the calculator. So we'll do point slope. Let's use t. Okay, so again, you would want to see that they are going to want to see that, and then they are going to want to see your step whenever you plug it in. Oh, so we are plugging in 3.5. All right, and then I'll add that 2.5 back over. Okay, so it looks like we're going to get 2.952. So an approximation for the amount of water at 3.5 minutes is going to be approximately 2.952 cubic feet. Okay, so the next question is asking us to find the second derivative of W of t. So and this is at time equals 8. So at time equals 8, we have water flowing in and we have water leaking out. So I'm just going to go ahead and write what W prime of T is at that moment. So it's going to be the inflow minus the leaking. Okay, so then if I want to find the second derivative of that, it's going to be F prime of T minus L prime of T. I'm just going to go back up here and say that this is W prime of T whenever we're using times between 5 and 10 minutes. Okay, so now I just want to go back and put 8 in. Okay, and then for the L prime of T and the F of 8 and the F prime of 8, you like if like in this case we could use the calculator. You may have to show your work finding those derivatives by hand. I'm hoping we get a little bit more information pretty soon. And even if you do have to do it by hand, if you guys can still check it in the calculator. Do in the alpha window. And number 3. Anyway, I did this earlier, and when I subtracted those, I got negative 0.183. That's the rounded version. The truncated version is negative 1 or 0.182, and those are both perfect. So we would write a little statement at time t equals 8 minutes. The rate at which the rate of change of the volume of water is decreasing at a rate of 0.183 cubic feet per minute per minute. Now I did see a note that it is okay that you, instead of, if you don't want to say decreasing because it's negative, you could just say changing by, and then you would need to say negative 0.183. But most of the time when we learned this, if it was negative, we would say decreasing and then use the absolute value. If it's positive, we would say increasing. Again, I would go back and use the words in the problem. So we know that W prime is the rate at which the volume is changing. And then we're dividing, and that's going to be in cubic feet per minute. And then we divide that by another minute, so it's cubic feet per minute per minute. All right, on C, we want to know, is there a time between 5 and 10 minutes at which the rate of the change of the volume of the water changes from positive to negative? All right, so what we would want to do first is find when the rate of change of the volume of water is 0, because the function would change from positive to negative after it goes through 0, basically. All right, so we want to find when and we can just do that on the calculator. So at that time, between 5 and 10 minutes, W prime of T is equal to F of T minus L of T. So we can find when that's 0. And again, we need to go to a bunch of decimal places. Actually, we don't really. We're not going to use, the only place we're going to use this is on the number line, so we don't have to go to that many, but it's fine. All right, so in the middle of this number line, I'm going to put this time. All right, and then I'm going to test w prime of t. So I want to find w prime of 8 and w prime of 9. And you would just go back up. For the f function, you would put in 8. And for the L function, you put in 8 and you subtract. Or you could go type, if it's already typed into your calculator under Y1 or Y2 or Y3 or whatever, you can go to the table to find it. Anyway, when you put in 8, you get a positive value. And we would do the same thing with 9. We put in 9 and we get a negative. So there is a place where the function w prime of t, or the rate of change of the volume of water, changes from positive to negative. So at that point, more water is flowing out, or after that point, more water is flowing out than flowing in. So let's write it out. Yes, there is such a time because w prime of t is positive for 5 is less than or equal to t is less than or equal to that value where it's 0. Actually, we don't have equal to there because it is 0 there. And w prime of t is negative for the other side. All the way to 10. Now, it is fine for you to use this number line to show, show your work, but it is not an explanation. So when you do the explanation, you have to write it out in words. Okay, and then we have another related rates question to do. So the tub is the shape of a rectangular box that is 1/2 foot wide, 4 feet long, and 3 feet deep. What is the rate of change of the depth of the water in the tub at time t equals 6? Okay, so what we know is the rate of change of the volume, because this formula w prime is the rate of change of the volume. And so we'll have to plug some stuff in. So for our formula, we're going to use the volume of a rectangular box or a rectangular prism. All right, and then the length and the width of this prism stays the same. The tub is 3 feet deep, but the height of the water isn't always 3 feet deep. It goes up and down. So we would go ahead and put in the length and the width, and height is going to be our only variable. All right, so we would go ahead and find the derivative with respect to time. Now, what we were finding, this one is a little harder to write the given statement. We're finding dH dt when when time is 6. All right, so we are given dv dt. We just have to find it. So dv dt at our magic moment, t equals 6, is just found by doing w prime 6. And 6 minutes, there is the water is leaking out, so it's going to be f of 6 minus l of 6, which is 0.050058. All right, so we will go ahead and put that back in. And then we can solve that for dH dt, which is what we're looking for, by dividing by 2. Okay? And so we will get that dH dt is equal to 0.250. And then you would want to write a statement that the rate of change of the depth, I just want to word it the way they did in the problem, of the water